1 and apoptosis by metformin to decrease tumor resistance to adriamycin. Adriamycin is an anthracycline antibiotic that is frequently used as a treatment for many types of cancer, including leukemia, lymphoma, breast, ovarian, and lung cancer. It damages DNA by intercalation into DNA and inhibition of an enzyme called topoisomerase 2, resulting in DNA strand breaks. The major limiting factor for the use of adriamycin in cancer therapy is the development of resistance. The mechanisms of this resistance may include increased activity of sphingosine kinase 1 enzyme, which inhibits penetration and intercalation of adriamycin into DNA and significantly abolishing the anti-cancer effect of adriamycin. This makes it essential to combine adriamycin with agents that inhibit these mechanisms to decrease the incidence of resistance of cancer cells to adriamycin. Metformin is a famous antidiabetic agent that decreases intestinal absorption of glucose, increases its anaerobic metabolism, and improves insulin sensitivity. Studies on animal models had demonstrated that metformin prevents tumor development and inhibits cell proliferation. This effect may be mediated through its regulatory role on the hormonal, metabolic, and immune functions. The main molecular target for metformin is adenosine monophosphate activated protein kinase signaling that plays a crucial role in the control of cell division and proliferation. Moreover, metformin had been shown to improve endothelial function, decrease inflammatory response, and regulate immune functions which have a major role in the pathogenesis of cancer. Also, metformin was proven to inhibit sphingosine kinase 1 activity, which was one of the main factors contributing to resistance of cancer cells to chemotherapy agents, especially adriamycin. Also, metformin was proven to inhibit sphingosine kinase 1 activity, which was one of the main factors contributing to resistance of cancer cells to chemotherapy agents, especially adriamycin. So, the aim of this work was to study the effect of targeting sphingosine kinase 1 and apoptosis by metformin on tumor resistance to adriamycin using a transplantable tumor model in mice. In our study, we used a model of solid Ehrlich carcinoma, where Ehrlich carcinoma cells were implanted subcutaneously into the right thigh of the hind limb of mice. A palpable solid tumor was developed within 10 days. This is Ehrlich ascites carcinoma, used for induction of solid Ehrlich carcinoma. This photo represents the control mice and the solid Ehrlich carcinoma mice after implantation of Ehrlich carcinoma cells. 100 palp-C mice were divided into 5 equal groups of 20 mice each as follows. Group 1 was the control untreated group. Group 2, Ehrlich carcinoma cells were implanted subcutaneously into the right thigh of the hind limb of mice. In group 3, adriamycin was given by intratumoral injection on days 10, 15, 20, 25, 30, and 35 after implantation of Ehrlich carcinoma cells. In group 4, metformin was given to mice orally starting 10 days after implantation of Ehrlich carcinoma cells and continued for 32 days. Group 5, adriamycin and metformin were given together starting 10 days after implantation of early carcinoma cells and continued for 32 days by the above regimes. Tumor volume was measured on days 15, 20, 25, 30, 35, and 40 after implantation of early carcinoma cells. In the 42nd day after implantation of early carcinoma cells, the animals were killed and the tumor was excised and divided into two portions, one for homogenization and the other for histopathological examination. The tumor tissue was homogenized for determination of tissue catalase, glutathione reductase, malondialdehyde, sphingosine kinase 1 activity, caspase-3 activity, and tumor necrosis factor. This figure represents the effect of different treatments on tumor volume. As you see, administration of either adriamycin or metformin resulted in significant decrease in tumor volume compared to solid early carcinoma group, but the combination between the two drugs leads to significant reduction in tumor volume compared to the use of either adriamycin alone or metformin alone. The effect of different treatments on tissue antioxidant parameters. As you see in this figure, implantation of early carcinoma cells resulted in significant decrease in tissue catalase compared to the control untreated group, but the administration of either adriamycin or metformin resulted in significant increase in tissue catalase compared to the solid early carcinoma group, but still the combination between adriamycin and metformin resulted in significant increase in tissue catalase compared to the use of either of these drugs alone. This figure represents the effect of different treatments on tissue malondialdehyde. In solid early carcinoma group, there was significant increase in tissue malondialdehyde compared to the control group, but with the administration of adriamycin or metformin, there was significant decrease in tissue malondialdehyde, but the combination between the two drugs produced more significant effect. Also, this figure represents the effect of different treatments on tissue glutathione reductase enzyme. Here, implantation of solid early carcinoma resulted in significant decrease in tissue glutathione reductase compared to the control group, but with the administration of adriamycin or metformin, there was significant improvement in tissue glutathione reductase, but still the combination between the two drugs produced more significant effect than the use of either of these drugs alone. This figure represents the effect of different treatments on tissue tumor necrosis factor alpha, which is an important pro-inflammatory cytokine. Here, the implantation of solid early carcinoma cells resulted in highly significant increase in tissue tumor necrosis factor alpha compared to the control group, but the administration of either adriamycin or metformin resulted in significant decrease in tissue tumor necrosis factor alpha compared to the solid early carcinoma group, but still the combination produced more significant effect. This figure represents the effect of different treatments on tissue caspase-3 activity. Caspase-3, as you know, is an important in the apoptosis. So, with solid early carcinoma group, there was significant decrease in tissue caspase-3 activity compared to the control untreated group. But the combination between adriamycin and metformin resulted in significant increase in tissue caspase-3 activity more than the effect of using either adriamycin alone or metformin alone. This figure represents the effect of different treatments on tissue sphingosine kinase 1 activity. Here, implantation of solid early carcinoma cells resulted in significant increase in tissue sphingosine kinase 1 activity. And with administration of adriamycin, still there was significant increase in tissue sphingosine kinase activity. So, administration of adriamycin produced insignificant effect on tissue sphingosine kinase 1 activity. But metformin decreases the activity of tissue sphingosine kinase 1 activity, and the combination between adriamycin and metformin resulted in more significant effect on tissue sphingosine kinase 1 activity compared to either adriamycin or metformin alone. This figure represents the effect of different treatments on the apoptotic index. Here, in solid early carcinoma group, there was significant decrease in the apoptotic index. I mean, there was significant decrease of apoptosis. But with administration of adriamycin or metformin, there was significant increase in the percent of the apoptotic index, but the combination between adriamycin and metformin resulted in more significant effect on the apoptotic index compared to the use of either adriamycin or metformin alone. These photos represent H&E stain sections of a solid early carcinoma group, showing sheets of small tumor cells representing cell proliferation surrounding areas of necrosis. B represents adriamycin group, showing focal necrosis with sheets of malignant cells. This necrosis represents the effect of adriamycin on the cancer cells. Also, C metformin group show focal necrosis. D represents the effect of adriamycin metformin combination, showing extensive necrosis more than the use of either adriamycin alone or metformin alone. Also, we perform staining, immunohistochemical staining of tissue sections for B53, which is important tumor marker that is overexpressed in solid early carcinoma. The photomicrograph A shows that in solid early carcinoma group showed absolutely negative staining for B53. With the administration of adriamycin, there was positive +3 B53 expression. With metformin group, it shows positive +2 B53 expression, but with the combination group, there was very strong positive +4 expression for B53. So, from our results, the combination of adriamycin and metformin had a better effect than the use of each of these drugs alone against the transplantable tumor model in mice. This might be due to the combined antioxidant and the anti-inflammatory properties of both drugs, together with their ability to induce apoptosis of cancer cells. Moreover, metformin was able to decrease sphingosine kinase 1 enzyme activity, which potentiates the effect and decreases resistance of cancer cells to adriamycin. So, it is recommended to add metformin to the anti-cancer regimens containing adriamycin to decrease resistance of cancer cells to adriamycin. Thank you.
Thank you very much, Dr. Kabel. We can have 1 or 2 questions, please. Yeah.
I wonder whether the metformin is much better than
I wonder whether the metformin is much better than one of the MDR inhibitors, phosphoglycoprotein inhibitor. Yeah, phosphoglycoprotein inhibitor. It is a multi-drug resistant transporter. There's some inhibitor, so that by inhibiting multi-drug resistant transporter, which is actually P glycoprotein, it is a highly effective to shut down the drug efflux. So having compared the activity of the metformin with those a very well defined MDR inhibitor.
You want to compare the effect of metformin in different doses?
But it as not in real experiment, but in reference. Also, how did you do the metformin as well as adriamycin? Have you injected into the same thigh?
As regard to metformin, I give it orally by dissolving it in drinking water at a certain concentration and giving it orally to mice daily for 32 days after the development of the.
So it is not injected to the
no.
side?
No. But as regard to adriamycin, it was given by intratumoral injection at certain days after the appearance of solid cancer.
Any other questions? Okay, please. Just, I'm sorry.
Very interesting data. It's just I was wondering about the concentration of the metformin used and its relation to the antiglycemic dose that we use for the metformin. So, are we suggesting adding it to the formulation of the doxorubicin or the adriamycin in one and same formulation and forgetting about being like antiglycemic, or are we very close to the doses?
First of all, I ask you, is metformin decrease blood glucose below the normal level?
No, that's not the mechanism.
It is aglycemic drug. So in our study, we used a certain concentration. It is 200 milligram per milli of drinking water because this concentration was based on previous studies and normally metformin doesn't affect the blood glucose, doesn't decrease blood glucose below the normal level. This may be done with drugs that are hypoglycemic drugs, but our drug today is not hypoglycemic, it is euglycemic drug.
So the concentration given or the dose given was quite similar to the one given for the, is it comparable to the dose given as for the metformin?
Yes, it was equivalent to the dose given in and we based on the previous literatures which used the same dose in